Because we'd like to simplify this expression by subtracting these two separate fractions, we're going to get them a common denominator first, and we're going to do that by multiplying the first fraction by cosine theta over cosine theta, so just multiplying by 1, not changing the value. And we're going to multiply the second expression, which already has cosine but doesn't have sine theta, by sine theta over sine theta. And this is going to give us a common denominator of sine theta cosine theta. So we'll end up with secant theta cosine theta over sine theta cosine theta. And from that we're going to be subtracting sine theta times sine theta over sine theta cosine theta. And we can simplify this into one fraction and combine those two signs. We'll end up with secant theta cosine theta minus sine squared theta all over sine theta cosine theta. Now from here, to simplify a little further, we can remember a reciprocal identity that secant theta is the same as 1 over cosine theta. So we can plug that in. Everything else is going to remain the same. But you can see now, because we have 1 over cosine theta times cosine theta, that that's going to reduce down to 1. We can simplify that out. So we'll have 1 minus sine squared theta all over sine theta cosine theta. And here we can use a Pythagorean identity to change 1 minus sine squared theta into simply cosine squared theta. And that's still over sine theta cosine theta. And that's going to equal cosine of theta times the cosine of theta in the numerator over the sine of theta times the cosine of theta. Now we can cancel one of the cosines from the numerator and denominator, which will leave us with cosine theta over sine theta, which we can simplify to our final answer, which is the cotangent of theta.